Hey folks, welcome to the stream. How's everybody doing? It's been a little while. I've had a bit of actual, life, real life admin to deal with and sorting out adulting stuff. And also, I kind of hit a point with the stream where I think you folks were spending a lot of time watching me being stuck. So I took a couple of days off and I reworked a whole bunch of stuff and I solved some of the little annoying problems that were like pushing a GitHub Actions build and watching it fail and putting in a commit that the commit message just says changed a thing and then pushed it again and pushed it again and pushed it again. And you do this kind of every 3 minutes for about 7.5 hours. And eventually, hey Jake, hey Marie, hey Surly, welcome to the stream, folks. Folks, I have the window open. It's beautifully warm and sunny here in London. If there is traffic noise, you let me know, and I will close the window, because I do live on a main road. And you will almost certainly, in the next couple of hours, you will get somebody going past in a BMW with all the windows open, playing very, very loud, aggressive music, which is fine. We can live with that. Yeah, it's a bit sweaty. England does heat, but England doesn't really do dry, even when it's not actually raining here. There tends to be a certain amount of humidity. Anyway, so awesome things are happening with Rockstar 2. What I have done, I've ripped the whole thing apart. So what I have now, all the stuff that we were figuring out on the stream the last couple of weeks, that is now in a branch. And the branch is called One to Throw Away. Let me bring up the GitHub repo here for that. And if I go into the Rockstar lang and hit up the Rockstar 2 thing, which we got in here, yeah, there is now a branch on this called the One to Throw Away. And what this has all the right bits, and they are assembled terribly. So, you can't be naked on the internet, Sully. That's not what this was invented for. And let me move. There we go. I'm out of the way a little more. So, what I've got here is I got this repo. Now, this one, I got to the point where all the tests in the Rockstar test suite were passing, but some of them were taking... so Andreas says, am I going to experience the birth of another esoteric language? So, kind of yes and kind of no. Rockstar exists. Rockstar has been a thing since about 2018. This is version 2, and this is porting the whole thing from JavaScript to .NET. But the really, really exciting part is kind of all the, I think, and I hope this is not me being prematurely optimistic, I think all of the technical issues which could have been like hard blockers, deal breakers for the whole project are now out of the way. Because if you go to beta.codewithrockstar.com, what I've got here, so this is still very much work in progress, but what I've got is, you go into one of these. Now this is the site here, this is built in Jekyll, so it's running on a Ruby engine using Jekyll, a liquid templating engine. It's got just the docs theme. Yeah, look at that, we got dark mode and light mode. And every one of these little snippets, so this is a Rockstar program that is part of the test suite. So when I build the interpreter in .NET, it is going to run and test every single one of these little programs. But then they are now embedded in a code mirror editor with a WebAssembly-based interpreter. So I can go into here and I can change this to be like print, hey chat, hope you're enjoying the stream. And we can, oh, there we go. And so we get little bits of syntax highlighting and almost like a REPL loop. So there will be a real REPL loop. I'm going to build one of those in. I just haven't figured out yet the best way to do that on the web. But what we do have is, yeah. And so every single thing in this, so for me, what's really powerful about this pattern is that every single bit of, no, this is not enterprise software. You can tell it's not enterprise software because there have been 0 meetings. No meetings. This is fun. This is craft. This is me spending my time building things that solve all of the headaches that stopped it being fun in the first place. The things that stop software development being fun, one is when it doesn't work and you don't know why. 2 is having to do the same thing over and over and over again because it's tedious, but you haven't figured out how to automate it yet. And 3 is, like, I like being able to tell people yes when they ask for stuff. And Rockstar, a lot of people have interesting ideas for it, and I really like the idea of being able to quickly try out those ideas, see if they're gonna work, and if they work, plug them in. So 1, when it doesn't work, you don't know why. 3, when it works and you don't know why. 4, when you figure out why it doesn't work when it worked yesterday. And 3, when you now have conclusively proved that it never worked. I had this the other night. I had a GitHub Actions build that, like Tuesday about midnight, it worked, it was green. Came back to it on Wednesday, and it didn't work. And I thought I hadn't changed anything. And I was like, that worked. That worked. Of course, Surly says doing the same thing over and over and over and over and over. We had an incident this week, CrowdStrike, whatever it's called, where there were people saying if you reboot your machine 15 times, it might work. Anyway, we're not here to talk about that. So yeah, I've got this little built-in interpreter here. So I love this. This is the Markdown kitchen sink. So this is just the page that shows absolutely everything that I've got in my theme, so I can check color schemes and labels and buttons and all that kind of stuff. And so all this stuff works. So what I've got now is pretty much like I am now 99% confident that if I can make something pass in .NET in nCrunch, then it will just go live on the web. Now this is fun. One of the things that I implemented this week, because it seemed like a good idea, was, so I started out with string concatenation. So addition, so 1 plus 2 is obviously 3, 1 plus the string 2, well that's obviously going to be 12. So what I can do in here is I can say, so print 1 plus 2, yep, and that's going to be 3, and print 1 plus 8 is going to be 9, and print 1 plus 8, so if any of these is a string, it falls over to string concatenation, just kind of like how JavaScript does, and I don't know, Surly, but I heard about on Reddit from somebody whose company was responsible for something like 75,000 Windows nodes that all needed manual intervention and BitLocker keys putting in. So if you glue strings together, now what I decided is that null will always work out as 0, so anything plus null is whatever you had anything. Mysterious is undefined, so anything involving mysterious, well, okay, I don't have the literal for that. We'll fix that today. 1 plus true, so true is always going to be 1, so you can do, JavaScript-y true plus true is going to be 2. And then I was like, all right, so we got that, so that's printed in the wrong code. We'll fix that in a second. But then, I looked at string multiplication, and I'm like, well, yeah, if you have 2 times rock, obviously that's going to be rock. And if you have true times 2, that's fine, and then I thought, well, what if you multiply a string by a negative number? I'm like, well, that would reverse it, right? It's like one-dimensional matrix arithmetic. You think of a string as a matrix of character elements, you multiply that by -1, you get the inverse matrix. So, yeah, so rock times -1 is KCOR, and rock times 1.5, I thought, well, obviously, if you multiply something by half, you get the first half. So rock times 1.5 is rock row, because it takes the RO off rock and pulls that in. And then rock minus 0.2 is going to give you 20% of the string rock after reversing it, which is all, fine. Makes perfect sense. And then I thought, well, if we can do that, we might as well do division. So string division is now, I think Rockstar is the only language in the world where string division is strongly defined. And what it does is if you divide a string by 2, you get half of it. If you divide a string by 5, you get the first 20%, the first fifth. If you divide it by -1, yep, dividing by -1 is the same as multiplying by -1, you get string reversal. Divide by -2, you get half of it backwards, because why would you not get that? And if you divide a string by another string, so if you divide haystack, haystack, needle, haystack by haystack, it gets 3. Because how many times does haystack go into that string? 3 of them. How many times does needle? 1 of them. How many times banana? 0. So there we go, and that works. That's in, that's done. So I've got strongly defined plus, minus, times, and division for every type in the language, including strings. The only thing I haven't figured out yet is division by 0, and what should happen when you divide something by 0. And there is a temptation just to say anything divided by 0 is 11, because, goes up to 11, Spinal Tap, that's one louder. I wonder whether that might make life difficult. So anyway, but the feature that we're going to implement today, or the first feature we're going to implement today, is something called compound or expression lists. So there are 2 things that I need to add with the language. So one of them is I want to be able to say 1 plus 2, 3, 4, and 5. And I want to be able to stack up expressions, and that will be 1 plus 2 plus 3 plus 4 plus 5. And I want to be able to say 10 minus that, and I want to be able to say, this kind of thing. So What would be the root or the power of a string? So, so the power of a string. I mean, so there's a part of me thinking, if you have a string like apple, and you have apple squared, well, surely apple squared is going to be this, because it's just going to make a square, which is the same as the string apple, right? Only apple, 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 apple. So that's squaring it. The root of a string, I don't know. But it's all right, because Rockstar doesn't have exponentiation or roots or modulus. Those are not defined. If you want to add those, you're going to need to write functions to do that yourself. So, so multiplying a string by 0 gives you an empty string. If you go over into Rockstar now and you shout hello times 0, that's going to give you nothing. You can't see it there, but that is the empty string. It prints nothing. So yeah, multiplying a string by 0 is the same as multiplying a number by 0. It gives you nothing. Gives you nothing back. All right, so what I want to do here, we're going to implement expression lists. And I want to be able to say print 1, plus 2, 3, 4, and 5. And by the way, there's a little linguistic quirk here. That on its own, that is going to apply a Boolean operation to 4 and 5. So it'll give you the logical OR of 4 and 5. Whereas 4, comma, and 5, the Oxford comma, turns that into an expression list. So there we go. So what I'm doing here, first we flesh out a bunch of test cases for stuff that should work. So that's print 10 minus that. So now I want to print, so what am I have? 27 divided by 3 and 3. That should print, so 27 over 3 is 9, over 3 is 3. And let's print 1 times 2, 3, 4, and 5. That should print string operations with numbers. Oh yeah. Well, actually, it's not string operations with numbers. It's numeric operations with string arguments. But, you know, the thing with, all of this is when you define some feature or operation in a language, you got to make a decision about in what circumstances is it going to work and in what circumstances is it going to fail. And if it fails, bear with me a second, folks. I've got a thing tangled through a wire here. Too many microphone stands around the place. There we go. That's fine. And yeah. So yeah, and I just thought, well, I've got all these things where JavaScript returns nan, not a number, but I'm like, well, we could do something. It might be potentially useful, but mainly it's because it's funny. Like, how many languages are there where a string divided by another string is not only supported, it is predictable and potentially even useful. So yeah, welcome to Rockstar, friends. This is not Rust. So what do we got? 1 times 2, 3, 4, and 5 is 1 times 2 is... That's all right. Don't worry. It's chill. It's Twitch. It's very relaxed here. So 1 times 2 is 2, times 3 is 6, times 4 is 24, times 5 is 120. So that should do that. My world says baby, my heart says yeah. Now, I think there's a thing I want to implement here. There's a feature I want to tweak. There's a feature in Rockstar for assigning literals. If we have a look at values and variables poetic strings, so what this does, the keyword says here, basically, so Tommy says that is equivalent to Tommy is, and then that whole thing in quotes. It'll give you everything up to the end of the line as a string literal. But I think we need a way of, if the thing after says is not a white space character, then it should capture the whole thing directly. So, so the syntax for this will be something akin to a variable says I start with a comma, print a variable. Okay, so that should, and sure enough, boom, I have a, just get end crunch over here where the whole gang can see it. There we go, and that should have given me a failing test, which is good. So I got one thing failing here in the, let me shuffle a couple of windows around. There, that would seem to be a good way of doing this. All right, so I've got a failing test there, and that's failing with unexpected A at line 7, which is fine, because it has no idea how to parse this expression. So let me go into the rockstar.peg, which is the expression grammar for the language. And I want to find that, the rule, the assignment rule that picks up says. So if I search, okay, so variable says followed by, now at this point, I think I need either a one of those, or I need something which is not a letter. I think that syntax will support that. And now if we rebuild, that should recompile the grammar, and those tests should, all right, that's interesting. Cannot convert string to generic list of string. All right, so I'm going to drop another rule in here. So I'm going to put in a rule that says, so says followed by an underscore equals the says rule optionally followed by that or something that is not a letter, which is a look ahead, which is fine. So now that rule becomes that. Let me save that and rebuild that, see if we get something usable out of it. Okay, that's curious. So this is a slight frustration with Pegasus, the thing I'm using, and I'm sure it's not a problem with Pegasus. That's saying can't convert string to a generic list of strings. So what we got here is we got a rule that is saying, so variable says poetic string. Let me just see what we get if I do that. The return types of the parser rules can be problematic, or can be a little confusing. So that will be, all right, I'm gonna put a rule in there that says force this thing here to become a string. See if we can rebuild that. That should at least build the grammar. There we go, grammar's clean, and boom. So those tests have now passed. So now I can initialize expressions, string expressions, by starting them with something which is not a comma. Let me put another couple of test cases in this just to make sure. So a variable says I start with punctuation. Okay, cool. All right. Grab a window there and z that into the starship, back up a level, git add -a, git commit -m, poetic strings starting with punctuation are now supported. And let's just update the docs for that, because this is a enterprise grade joke. That's what this is. Values and variables, strings, poetic numbers, poetic strings. If the character immediately following the says keyword is not a space, it will be included in the string literal. There we go. All right, boom, done. Is enterprise grade joke or better or worse than a normal joke? So it's probably better. Most jokes don't have test suites and maintenance and people filing issues against them. So yeah, we're gonna bulletproof the joke, because why not? Sounds like fun. Okay, so let's go to compound arithmetic. So expression lists looks like that. So I want to be able to print 1, plus 2, 3, 4, and 5, which means I need this thing here to be defined. I need a way in the language of capturing and matching this thing here, which is an expression list. So let's go into our rockstar.peg. Now I'm going to open up VS Code here, and I'm going to use code to open recent. Somewhere in here there should be something called Rockstar 2, the one to throw away. There it is. And this just gives me a place where, because I've solved all these problems in isolation, just the solution ended up being a bit of a mess because I was figuring a lot of it out as I went along. So if we go into our rockstar.engine here, I bring up the rockstar.peg. Now somewhere in here I had an expression list. So there we go. So an expression list looks like... there we go. So it's a head or a tail, or it is a... Now this is... There's a decision to be made here about what kind of expressions you can put in a list. And the reason is that there is potential ambiguity in the language. So let's imagine we had an example like this thing here. So let's print print 1 plus 2, 3 with 4, 5, and 6. Now for addition, this doesn't matter. It is clearly defined, but it isn't clear where this is going to print 1 plus 2, 3 plus 4, plus 5 plus 6, or whether this is going to print 1 plus 2 plus 3 plus 4 plus 5 plus 6. You see there's a, it's not clear whether this is print 1 plus 2. If we substitute that with x, that is now 1, 2, x, 5, and 6, or 3 with 4, 5, and 6, that's a valid sub-expression. When dividing strings, which bit do you get? And how do you get the other bit? So dividing strings, you get the... so if you divide... So banana divided by a is going to be 3. Because what it does, it tells you how many a's there are in banana. Just like if you do 6 divided by 2, it gives you 3, because that's how many 2's there are in 6. Yeah? And if you do banana divided by na, that is going to give you 2, because there are 2 nas in banana. Yeah, so that's how that works. That's online. You can go and play with that right now. It's built. It's real. It's implemented. So I need to put a test case in here for making sure these things are going to work, which is going to be print. So if I do 1 plus 2, 3 divided by 4, 5, and 6. All right. So that will either need, I'll need to define either what behavior we expect to come out of that, or I need to define what error message that should throw. And I think the rule that I'm going to put in here is that the things in an expression list, they have to be what are called primaries. So a primary is something which yields a value and doesn't involve any operators. All right, let's try plug in the grammar and see what we get out the other side. So we've got in the rules here, an expression is a Boolean or a primary. Then Boolean locks you into your whole is one of these, which is one of these, which is one of those, 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 which is one of these, which is one of those. And so what I want to do now is I want to plug the thing in here. And so the thing on the right-hand side there, that can be a primary list, I think is probably a better name for it. So the grammar for a primary list here, a primary list is going to be defined as a, okay, so I use simple expression as the alias in here, but actually this is fine. So what I'm going to say in here, this thing, a primary list returns a list of expressions, and it is either a head, which is a primary, or it is a thing called an XLS, which is a XL expression list separator, but I might give that a slightly more meaningful name, primary list separator, and then the tail for that is a primary list, and that returns head.concat tail, or it is a new expression which is a primary, and that just returns a new list with one thing in it. So that gives us the grammar, which means now that rule there, primary list separator, now the rule name here starts and finishes with an underscore, because that's an indicator that you don't put white space between the tokens in the grammar, because this particular token may or may not include white space that gets consumed as part of consuming the token. So, and I actually need to put another thing in here, which is that one. So we've got optional white space, then a comma, or the literal string and, followed by white space, or we've got, yeah, okay, so I think that's good. So this should now compile. Okay, expression does not contain a definition for concat. That's cool, we can fix that. So let me go into expression here, which is in rockstar.engine.expressions, and I'm going to drop a method in here, public list expression concat, and this is going to take an IEnumerable of expression tail, and this thing is going to return new list expression contains this dot add range tail, and that will need Taiwan lunisolar calendar is obviously what I was going for there. Thank you .net. I wonder if I can do that. There is no target type for the collection expression. So close to working, but no. So that is going to have to be a new list of expression, which is initialized with a single value, which is this, and dot add range tail, and that probably needs to return. Is it an IEnumerable? Do we want to do that? Why is that? That should work. How did I do this before? I have one to throw away. How did we do it in the one to throw away? Let's find the concat method, which is in here somewhere. Expression.cs. Open that up. No, that's doing lists all the way down. Since when did add range return null? Ah, that's using a concat. I've got another concat in there, which is defined as there. All right, let's try that. So that is now saying I can't do that, but if I return that, So IEnumerable is one of those things in .NET I'm always like, really? Is this, like... Because I don't need to know how long this thing is, I just need to know whether there are things in it. So that works. Alright. That's kind of fun. So now, what we should get is those should... Ah, no, okay. So I've got the rule in there now. Our primary list exists. I haven't told it to use it anywhere. So I'm going to go into this, and I'm going to say that these two rules here, so one of them is a product here can be a product multiplied by a primary list. So that works. And also a... I think I need to define another alias in here, because I think this one needs an explicit rule, because you can add to a list of primaries, or you can add to a product, which is an expression, but you can't add to a list of products, because then you get this ambiguity around which part of the syntax captures the comma. So let's, this can be a left-hand side is the addition, then the operator, which is going to be a plus or a minus operator, and then the right-hand side can be a primary list, and that will just return a new binary, op, left-hand side, right-hand side. Okay, I thought that was gonna happen, so, but that's fine, because what I need to do now is go into binary and define the, there, that comes out, and that becomes an IEnumerable of expression on the right-hand side. I may turn all these back into lists. All right, so that runs all the way through. And so we're still getting unexpected comma, which means that the rule, the parser rule in there can't pick that thing up. So 1 plus 2, 3, 4, and 5. All right, so a diagnostic technique that I've taken to using with this thing is that should be a valid arithmetic expression, right? So we've got that thing there. So I'm going to stick a rule at the top of this, which is a hard-coded rule that says 1 plus 2, 3, 4, and 5. So that should be an arithmetic expression. I'm hard-coding it to make sure we're reaching the correct point in the grammar, at which point I am going to return an error, and I'm just going to say boom. And so now when I rebuild that, I'm hoping I'll get a boom down here, because that'll tell me that I am in the right place in my grammar, and I'm not. All right, and that's interesting, because if I rebuild that, that's gonna build, so the grammar's clean, but it's still saying there is an invalid... Oh no, boom, we got it. Okay, we're in the right place, that's good. So that works, so we're getting down as far as here. So now what I wanna see is, can I create a rule here, which is a left-hand addition, followed by that, followed by 2, 3, 4, and 5. Boom, okay, good. Same thing. Maybe I just need to switch the order of the rules here. So if I take that rule out, including its alternator, and I drop it in here. Now what's happening here? If it goes boom, it means that this top thing is not matching. The top thing is matching. Yes, all right, cool. So the primary list, that needs to bind first. That needs to be tighter than the rule that looks for a product. So that comes up to there, which means that comes down to there, which means that we probably don't need. I was expecting that to work. All right. So let's try creating a rule here that says that a primary list can be the exact string that we are currently failing to match here. So I'm going to say a primary list here is 2, 3... Ah, no. That 3 divided by 4. You remember I said that wasn't going to work? Yeah, that's not supportable. So that bit needs to come out. So expression lists.rock, that comes out. That's back to our grammar. We fixed that. Rockstar.peg is there. Okay, so what I'm expecting now is a runtime error for the interpreter. Okay, cool. Yeah. Nice. So this thing is now saying, all right, well, you've got your expression lists, and we were expecting that to print 1503. So it's working, it's doing the right thing, it's just not extracting the right test cases. That needs a prints on it. I'm stupid, yeah. So that prints 120. That prints, what's 1 plus 2 is 3, plus 3 is 6, plus 5 is 11, yeah, that prints 17. And that prints, so I just can't write code in my own language. The silence, the tension. There we go. Interesting. I have broken basic arithmetic. I need a rule that says that a expression list has to have more than one thing in it. Which is surprisingly difficult. No, I don't. We're fine. It's all right. What I need is a rule in here that says that a product is either a product times a primary list, or it is a product times a primary. Or it is a... Yeah. I need two of these. I need... Because you can't match a list if you've only got one, because then... Can you? So by the time you get down to here, that shouldn't matter. But at the point when you're here, we got something plus a list, and we got something... Yeah. All right. So first thing I want to check here, if I comment at those two new cases, does that in fact fix that failing test? Just want to make sure that the thing I changed has broken the thing that worked previously. So that basic arithmetic should now both pass, and the new thing that we're playing with, that should now fail. Okay, good. That's what I expected. And if I plug that back in there... All right, good. So that's the rule that's broken it. So let me test a theory here. If I say that a primary list has to have more than one element, So this thing is gonna be a there. Ah. Cool. Okay, so that's all clean. That's all good. That's all in. That's all working. Question is, are there going to be scenarios now that this thing blows up against and fails on? And yeah. All right. I'm not going to solve problems I don't have yet. Currently, everything is green. Let's go into that expression lists. So yeah, that plus that plus that plus that plus that is fine. Yeah. Okay, so docs on this. So primaries are literal strings and numbers, variables, function calls, language constants. I think that's what I defined it as. If I go into rockstar.peg and I find the rule for primary, which is in here somewhere, yeah, constant string, numbers, lookups, yeah, that's fine. And if we have somewhere where we've got to have a primary and we don't, Guns, Games, and Guitar says, can you explain what you're doing like I'm a baby who only uses C#? That is excellent. Like you know, of all the things that a baby could possibly do, using C# is the best one. I am building a parser and an interpreter for an esoteric programming language called Rockstar, which is, so you can see the old version of Rockstar at codewithrockstar.com. Rockstar is based on heavy metal lyrics and hard rock songs, and it's an esoteric language, so I don't use it for anything real. It's just for fun. But what I've been doing on the stream the last couple of weeks is building out a grammar, a parser, and an interpreter, so I can basically ship a new version of Rockstar, because the old one was written in JavaScript. And as much as I love JavaScript, trying to maintain an entire language built in JavaScript is nobody's idea of a good time. So yeah, that's what we're doing. So a brief kind of overview of the way the project works. There is this thing here. This is called a PEG file. This is a technology called a parsing expression grammar, which uses a regular expression like syntax to define what the language looks like and to tell the parser, hey, when you see one of these, you want to admit it to when you see one of these, we want you to emit one of these. So like we've got a rule somewhere here that says, let me find an easy example. I don't think there are any easy examples left in this. All right, so we've got a plus operator, and this is saying, look, I want you to find, so the underscore here stands for white space, so I want you to find white space. The question mark means it's optional, so there may be some white space. Then you find a literal plus character, then maybe some white space, or the whole thing can be a different rule called plus, but if either of those rules match, we want you to return this operator. And those operators build up into an expression tree, and the expression tree is what gets fed into the interpreter, and the interpreter then runs the program and makes that work. So let's just take a look at expressionlists.rock, and so that's looking pretty good. Okay. Right, so I was just making a note about that. Functions, variables. All right. So a primary is anything which yields a value but does not involve any operators. So primaries are literal strings and numbers, variables, function calls, and language constants. The reason for the restriction pop quiz for Dylan. Rockstar Dev Energy. What? Ping. What? What? Rockstar Dev Energy equals ping 86.73.78 hint drop dots and use ASCII. Well, 86.73.78 is ASCII table. ASCII table. 86 is, that's decimal. V73 is I, 78 is N. Ping-vin. Now you have this is my lost face. I am very, very lost right now. So I'm going to go back to doing this instead. So, all right. Reason for restriction is that if you could put arithmetic expressions as arguments to other arithmetic Ping-vin! Yeah! Yeah, you're absolutely right. Hang on. I knew there was something missing. And I cleaned up my office. Because I'm going to be making some training videos. So, and the company I'm working with are like, don't use green screen, just you naturally in front of your room. And, yeah, the room is was not optimized for making high-quality professional content. So I had to clean things up, and I put all the licorice away. I forgot about it, but awesome. Right. Oh, yeah, now we're doing it. Let me see what Obsidian is going to do if I try and put a code block inside an indented expression. So ding, 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 Rockstar. So this would be shout 1 plus 2, 3 divided by 4, 5, and 6. All right. I think this will probably break Obsidian, but I think it will work when I deploy it to Jekyll on GitHub pages. Let me just double check that. Oh no, that's fine. That worked. Okay, good. I mean, it's properly screwed up the editor, but Oh no, there we go. We're good. We're good. We're good. We're good. We're good. Is there a shortcut key for that reading view? Alright, fine. So this is the fun part. Well, I say fun. What I'm struggling to understand is how a coding language is based on heavy metal. So what do you do with it? You have fun. You do Advent code. You teach people to build parsers. That's your lot. It's not for doing anything real. It's art. It exists because it makes the world a better place just by the fact of its existing. Alright, so that's there. So that's there. So that should, yeah, that should have worked. Alright, that's done. So now if I switch over to my browser here on localhost, I refresh that, go down here and hit rock. Alright, that's correct, unexpected comma. But if I go back to this window and I trigger that window, this is gonna build a new build of the WebAssembly binary that contains the Rockstar interpreter. And so that's going to build, this will take about 2 or 3 minutes because it's taken the entire .NET runtime, which is vast, like 20, 30 megabytes, and it is analyzing it to get rid of every single bit of it that does not get called by the Rockstar interpreter, which means it crunches the whole thing down to about 25 kilobytes, which is just such a awesome thing, and I love the fact that it's possible because it means I can use C# and I can build something that runs in a browser and it just works. And, you know, all right, so we're back to that in a second. While that's going on, I'm going to do a git add -a expression lists are working, and then yeah, git commit. I'm stupid. That should be a git add -a. Then I need git commit -m expression lists are working. Wow, my whole computer has just absolutely slowed to a crawl. Probably because that top window there, this one over here, this is currently trying to chop 28 megabytes out of the .NET runtime. Cool. All right, that's running. Compound expressions. So this is now so shorthand expressions like C++. So back over to VS Code, find that thing where I just wrote the expression lists, and we'll call this compound expressions. And so this one we're gonna say something like x is 1, x is with 2, print x, prints 3. What else have we got in here? We got my heart is empty. It's not blue screening. There have been no blue screens on the premises, which is very, very glad to report that. Had a bit of overheating though. Like I'm seriously thinking of taking my little cam links which are the things that turn the cameras into USB so that the computer can do it, putting them inside a piece of heavy-duty polythene tubing and submerging them in water the whole time they are running, because they get hot and it's very hard to heat sink them, because they just, yeah. Fans make a lot of noise, and liquid cooling is silent and effective. So X is 1, that's with that, X is with 2, print that. Y is 5, it is without 3, print it. Prints 2. My heart is like, let's come up with an interesting poetic expression here. A red rose. It is over... The moon is like fire. My heart is like a red rose. It is over the moon. Shout it. So that should print... Yeah, heat overheating memory, and memory causes memory errors, and when your RAM isn't reliable, you have no idea what you're doing. So a red rose is going to be 1334, and half of 1334 is going to be 667. That'll do. Okay. So that'll be 5 plus 4 is 9, plus 3 is 12, 15. All right. That's the test. The grammar. Now, how did I plug these things in? I think I plugged these in as... Let's take a look at what we did in the grammar over here. This is the one to throw away, so rockstar.peg in this file is there, and I had a I think they were assignments. I think that's a syntax, a variable for assignment. So the syntax that was supported initially is not x is with 4, it's let x be with 4. So one, I need to plug in a bunch of extra test cases for the other syntax here. So let's cover those. All right. So let me take a look at the expression. That's fine, that's blowing up. think that I can actually implement this entirely in the grammar, because I think, yeah. So if an assignable is operator assign operator expression list, then that becomes a new, yeah. All right. Let's try it. So we got a rule here, and this is going to be b is a variable is op. Do I have a rule for operators? Must be. All right, we'll define a rule for operators in a second. So if we see one of these, see variable is, so this is something like x is with 5. What this is going to return is a new assignment, and the target of the assignment is the variable, and the value of the assignment is a binary expression, which is going to take the operator, the variable, and the expression itself. So we'll drop in one of those. Now earlier we decided the primary list takes a higher precedence than that. So there's one of those. So if that is a primary, it can be an expression. That's cool. All right. See if the grammar picks that up. And more importantly, see if anything else is broken as a result of doing that. The rule operator does not exist. The referenced rule is does not exist. Is exists. I've used it. Okay. Hello, post-TV news. Working on is a difficult expression. I'm having fun right now. I mean, it's, you know, I'm doing sort of complicated brain stuff, but this is not my job. This is what I do in my spare time for fun. Right, so operator equals plus minus. All right, compound expressions. What is line 1? X is 1. Okay, so interesting. So I'm going to chop that lot out. Save that. See if it still blows up in the same place. All right. Okay, so let's reinstate those. Let me see if I can get this working with the existing syntax. Let x be with 2. Let it be without 3. Let it be with 3, 4, and 2, and 1. Let my variable be with bar and baz. Let it be over the moon. All right, so still unexpected Alexa line 1, column 1. Means I've messed up somewhere. And one of these rules is consuming something it couldn't consume and then failing, which is how we're getting through to the unexpected X at line 1. That's in the end of file rule. So that's saying, look, I started here. I tracked forward until literally the only thing left I was looking for was the end of a file, and nothing worked. Nothing yielded anything I could work with. So let's try that. All right. Let's try that. So that works. That fails. Good. So it is let x be with 2 is the thing that's blowing it up. That needs a space there. Curious. Bingo. Sweet. So what's happened there? The parser picked it up, the interpreter doesn't know about it now. But that's good, it means that works. So this rule operator, the problem is the rule operator, I need to give myself a clue. The operator includes its surrounding white space because that is not mandatory, it may be optional. So let me grab that, we'll go back into here. Now let's see if we can put back a couple of those other syntaxes we had in there. X is 5, it is without 3, print it. Let it be with 4, 3, and 1. Okay. So now I'm expecting all right. So I'm going to do the same trick again. I'm going to stick a rule in here which is hard-coded to the exact expression that we're looking for. Which is x is with 2. And I'm going to blow up there. Boom. All right, give it a second. System.format exception, boom. All right, so it is finding it. It is, the rule is getting there, and it's matching that. So now I'm going to say, well, instead of that lot, let's try that. Unexpected x, y, put a space in there. Is that going to boom now? Boom. All right, so that booms. That's fine. So let's try capturing the operator there. Boom. I know why it is. It's because all I've defined is a primary list, and it needs an overload that supports the expression as well. Variable is operator, E can be a expression. That works too. I think this will fix it. I think. I thought wrong. Primary list binds tighter. That needs to go first. And I probably want to move these rules up because they have a prefix match. They match the word let straight away. So if they don't see the word let, they'll skip the rule and move on to the next one. Whereas these ones don't know whether to run unless they've dug through and figured out whether the thing they're looking at is a variable or not. Let it be with 4, 3, 2, and 1. Okay. Same rule. That should be matching to here. No. Too many permutations. Okay. So we need let be operator expression. What other tokens are planned for the lexer? I'd suggest break the X unset. So break does the same thing as break. Break is like break out of a loop. Skip the rest of the loop and move on. I'm going to create a rule. So this is going to be a thing called a operable. Is going to return an expression which is either going to be a primary list or it is going to be an expression. Which means these rules then can become the same rule, and that can become the same rule. Build that. Okay, cannot convert expressions to a parse result of an IEnumerable of expression. So all right. Cool. All right, the parser has picked that up all the way down. Right, let me see if that... So first of all, I think that is probably not a great name for it. So I'm going to change operable there to be a binary right-hand side, which I can't do using refactoring because the refactoring tools don't know about expression grammars. So we're going to do a search and replace here. Going to find operable and replace it with binary underscore RHS. In current document, replace all. Cool. All right, close that. So now I want to find a couple of other places where I had a binary right-hand side. And actually, you know what? Let's get this working, and then I'll see what else I can clean up in the grammar. So, not implemented. Eval not implemented for simple variable. I need a lookup. That's what I need. So that rule there says that if something be that, the left-hand side of that actually needs to be a lookup expression based on that variable. Yep. And that one there, assign v to be a binary of lookup v and e. Build that lot. I love that. I love it when you can build something in the grammar. Sick of Metal, the language is Rockstar. HTTPS codewithrockstar.com. It is an esoteric language based on, well, when you say what language is this, the screen you are looking at currently is the parsing expression grammar definition for the Rockstar esoteric programming language. So this is a PEG file. parsing expression grammar. I'm using it to build Rockstar, and the interpreter is in C#. So it's a combination of languages. And there's JavaScript and Ruby in there also, because why not? We're sort of banging languages together to make a language Voltron. All right. The moon is like fire. My heart is like a red, red rose. Of course, fire is a 4-letter word. That should be 333.5, shouldn't it? Yeah. Come on. Come on. You can do it. Do you know what that means? Blank is good. Blank means everything is working. All right. So let me try. I just want to make these a little bit more advanced. Z is 100. It is over 5, 4, and 2. Shout it. And that should print 100 over 5 is 20, over 4 is 5, should be 2.5. Cool. Right, so that's compound expressions. In. Ship it. Where's my window gone? It's over there. So get that -A. Right. Now I think I need to reorganize a couple of things in here, because I have expression lists and compound expressions. To me, I think these should go in a separate section. So this should be all right. Cool, that's in. That's going to work. I got some random blank lines in here I don't need. So, why do people keep asking what you can do with it? You can do so. It's a Turing complete language with no network or file system support. You can use it to write songs that execute. You can use it to write programs that sound funny. You can use it to solve every day of advent of code, because somebody did that last year. It's a it's an esoteric language. It exists because the world is a better place for having Rockstar in it. That is the only reason. But that's a good enough reason for me. All right, so what are we going to do next? I'm going to rename that. And we are going to add a new folder. Called Logic. And a new folder called called I don't know. All right. naming things is hard. We'll come back to it. Alright, so arithmetic is there. Actually, we'll rename that. We'll just call it advanced expressions, weird expressions, more expressions. Expression syntax is probably a good one. Yeah, alright. So now compound expressions and expression lists, they can both go over into there. So now I need to go into the doc website thing. I need to right click, add a new note to this. This is going to be 04 is going to be logic, and I'm going to make a copy of that, and I'm going to call this one 05 expression syntax. Save those. So arithmetic has its examples in arithmetic. This whole lot, expression lists here, we're going to hoik that out. We're going to put that into here. So those are there, which means this one here, I need to copy the what's called the front matter, which is that lot. Let me go to source mode, copy that little chunk there. So 04 logic, drop in the front matter, expression syntax, drop in front matter, switch that back out of source mode. So arithmetic is there, examples are there. Binary logic has its examples in 04 binary logic. And 5 expression syntax has its examples in 05 expression syntax. All right, so 04, we'll rename that binary logic. Just because having the same thing called by two different names in two different bits of the project is an absolute recipe to spend the next 3 weeks going, other name. So there's subtraction, there's that, there's binary logic. Right, let's take a look and see if GitHub managed to build the last thing we threw at it. Rockstar 2 actions is there. Compound expressions are working. Okay, beta.codewithrockstar.com. Expressions, yep. Okay, and if we hit rock on there, we get 15, 0, 3, 120, baby, yeah. Great success. All right. What are we about to look at? Boolean logic. Okay. So Rockstar supports the following Boolean. It's not binary logic, it's Boolean logic, because it has a unary not, which is not binary. Yeah, okay, so that's there. That's for binary logic. That's cool. Right click that, rename that. And that is gonna be, rename that. Binary logic expressions using the keywords and, or, nor, and not. Rockstar also supports the unary So you can say a variable is totally non-true. which makes it true is false is true is false is true. All right, pinged in. Syntax. Shout true and true. Prints true. Let's actually put print instead of shout in here. All right. So right, basic logic. So ding, 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 bang, bang, include. So this is Rockstar syntax highlighting. Include relative, page.examples, basic logic.rock. All right. So that's in. So let's make it work. So first of all, we should have tests failing now. Yes, they won't parse and they won't run. So let's make them parse, then let's make them run. So we're going to bring up rockstar.peg, and we are going to say that a expression is a Boolean or a primary, and right, let's work this thing up from the ground up. So we've got a unary is either not a unary or it's a comparison. Right, now I should have a rule somewhere for not. So I've got not and I've got non. So I think I need to define a rule that includes the trailing white space, so it'll plug those bits together, so that that is going to do what we want. So let me find the unary rule there. So the rule we got here is not here is defined as either not or non or yeah, all right. The reference rule does not exist. It does exist. I wrote it. It's the add needs an equal sign, doesn't it? Rules only exist if you make them actually be something. Okay, that's cool. The type 1 namespace name not could not be found. This is all right. And what did I call not? Okay, we're going to make it a unary. Operator.not and u for whatever the expression was. All right. Okay. So unary needs to exist because I don't think I've got unary in this project yet. And unary is an expression that contains a value. So we can pull out that and that. And public unary, our constructor is going to take an operator OP expression expra is going to initialize. I can probably make that a primary constructor. Yep. Boom, boom. Let's initialize field op, and now I should be able to change that to cool. All right, that's in. That works. It builds. Now we right. I'm going to split that out. I'm going to change that file. Actually, I'm going to duplicate that file. Rename that to be unary not.rock. And so this one is going to print not true, not true. Sweet. Okay, so that parses. And then this thing says, eval is not implemented for Rockstar.engines. Hello, Stony. The stupidest languages come along brilliantly. I'm starting to have this horrible feeling like the stupidest language in the world is also the cleverest thing I've ever done. That's a weird place to be. Right, boom, let's implement unary. How does unary work? So I'm going to copy the logic here from binary resolve. Because what this does is gives us a whole bunch of useful stuff. So now we're going to switch on this. So if this is operator dot not, then we need to return, and this is where it gets fun. Because we need to implement truthiness. Okay, so boolean.not here, I need to plug in a method boolean.not, and what this is going to do is it's going to take a value v, and it's going to return a new boolean whose value is given by not v.truthy. So now we need to build truthiness. Truthy in value is a bool. Cool. All right, it's a bool. So, right, back into the docs. How's this thing going to work? Let's write about it before we get started here. Every possible value in Rockstar evaluates to either true or false, apart from mysterious, which will we'll make mysterious false. Mysterious can be false here. This is known as truthiness. The only things in Rockstar which are falsy are false, null, mysterious, the empty string, false, null, mysterious, the empty string, and the number 0. Everything else is truthy. it'll be true. Right. So, truthiness. First tests. Truthiness tests. I need my string extensions are no. Rockstar.test is here. Expression values, there we go. Right. Nah, that's where it gets fun. Yeah, Boolean. The reason for the diaresis, the umlaut on the Boolean, is that Boolean is already taken in .NET. It means something, and I don't want my Booleans getting in the way of their Booleans. We have strings as well, with a heavy metal umlaut on the stria. So, yeah, it's a nice way of namespacing. If you see a little heavy metal thing over it, you know that it's a Rockstar-y thing. Right. Truthiness test. So what do we got in here? We've got public void true is true. So this is going to be new Boolean right. Should white space be false? Probably not. Right. Let me plug this thing in. So I'm going to go into my value, which is over here. Value expression. What's that complaining about? I need to override a bunch of stuff. Yeah, that's fine. We fixed that. We fixed that later. Nope, scrub that. Hang on. Equality. Do I have equality testing in here yet? Yeah. So does that mean string defines the equality overload? Let's take a look. s2.equals is defined on value of use JetBrains tool, so why don't you use Rider? Because I like Visual Studio and I like NCrunch, and I know NCrunch works in Rider now, but old habits die hard, and every day you spend setting up a new tool and figuring out how to do the same job using a different stack is a day that you didn't spend doing the same job. That's why. Okay, let me see how I built this before, because I know the one I did before made a certain amount of sense. So let's take a look at value. So we've overloaded equals and not equals. Did I overload equality in here? No. Interesting. All right. Okay. Yeah, that's what I'm going to do. Because we don't want reference equality on value types. These need to have value equality. So that, I think, can become that. Which means this now becomes that. Right. Weird bunch of stuff that shouldn't have broken broke, but we'll come back and fix that in a second. All right. Oh, okay, so a bunch of things to plug in. So we got abstract bools, we got override bool equals that, so that's fine. We can plug that in there. That's cool. We got a toString override equals and get hash code. They can go in a block. We're gonna have a public abstract bool truthy. Yep, cool. Okay, so there we go. So let's implement some truthiness on here. So string, let's implement missing members on that. We've got an equals on a value of other. Now I thought string equality I'd already implemented here. Apparently not. So the return type for this. Hang on. So I can switch on the value, or the type rather. So that switch, value of t goes to equals t. Otherwise, not quite sure what we do there, but we'll figure it out, because when it blows up, it'll be obvious what we expected it to do instead, which is a lot more difficult to figure out in advance. Okay, so let's go back to string. And boom, and so we got truthy's good. That's in. What's that complaining about? Okay, so we just need to get it with something. All right. Number does not implement things. All right, missing members. Truthy returns value is not equal to 0. Boom, built that. What's next? Null does not implement truthy. Null is going to... what does get hashcode do on null in .NET? I guess 0? Jeep Monkey says, sorry to be cheesy, the art of code inspired me immensely and got me into programming. That is awesome. That is not cheesy at all. That is fantastic. I am so happy to hear from folks who enjoyed that and found it inspiring, and it sort of set them, because this is great. I love programming, I really do. Right, null is always false, and get hashcode on it is always going to be 0. Mysterious does not implement the things. All right. Mysterious doesn't equal anything, not even mysterious. There we go. Truthiness is always falsy. And a Boolean's truthiness is its value. Sweet, and look at that. Whatever I just did, I have 77 failing tests. Oh, cool, and they are all that exception that I just threw in. That's interesting. The reason it's interesting is I didn't think I'd built in anything yet that does equality checks. Oh. Ah. All right. Yeah, obviously. Right, why is values and variables assignment blowing up? That's why. Actually, that can just be this, can't it? Sweet. Give me a second. The Daystar, it burns us. So I love sunshine and I love computers, and I absolutely hate trying to use computers in sunshine. Later I will go away from the computers and enjoy the sunshine. And why is null.instance never being used here? It should be. Yeah, it is. It is. Alright, it is. It's just you can't see it for whatever reason. Alright, cool. Alright. Cool. Alright. Not true, not false, non-true, non-true. Yep. Numbers, strings. Now let's just move that down a little bit. Okay. So there we go. So basic logic. First, let me stick that lot in. Get add. All right. So binary NOR, binary OR, binary AND, equality. I'm ever so slightly skeptical that these are in the right order, but let's flesh them through one by one and see what do we get. So let's go into basic logic here. So we got true and true, true and false, false and true, false and true. That's all. We picked up the knots. What does NOR do? Not A or B. Yeah. One naught naught naught. Yep. True and true, true and false, false and true, false and false, true or true, false or true, false or false, true and not true, yep. Right. Grammar says Boolean equals a binary NOR. So a binary NOR here is gonna be a binary OR with a NOR keyword after it. Followed by a binary NOR, in which case we return a new binary. So at that point, that's the left-hand side, that's the operator, that's the right-hand side, at which point we return a new binary, op LHS RHS, or it is a binary OR. That's going to blow up unexpected character, because that should be one of those. The reference rule NOR does not exist. Now there is a rule down here. I think NOR is, yeah. Cool. All right. So then a binary OR returns an expression and is defined as a binary AND or a RHS is a binary OR. So left-hand side is one of those, binary and right-hand side is a binary OR, in which case we return a new binary. The operator is operator.or, or it can be just a binary AND on its own right. And then a binary AND is either gonna be an equality expression on the left, followed by that, followed by AND, followed by that, followed by right-hand side is gonna be a binary AND, in which case it is a new binary, operator.AND LHS RHS, or it is gonna be a equality on its own. Built that. And I just need to qualify those as expressions. So that goes in there, that goes in there. Cool, we get all the way down. Look at that, boom. So parsed straight away, the parser is green, the interpreter is saying, hey, exception, I don't know how to parameter op, actual value was NOR. And that is coming from here. And I'm gonna change that, so this should be throw new. I don't know how to apply op to all right. Don't apply to how to apply. I don't know how to apply nor to Boolean. All right. So we need to create falsy. Create property falsy. What is falsy? Falsy is not truthy. Yeah, that's that needs to be there. I don't know how to apply and to Boolean. Well, yeah, all right. Don't know how to apply or to Boolean. Let's build that one out. That's cool. Sweet. Look at that. We have Boolean logic. Hello, off-course roaming. Sorry, General Kenobi is the, I believe, the mandatory response. All right. Did that work? Like, that feels deceptively... Right, let's check operator precedence for binary logic now. So we got basic logic, programs, 04, basic logic. Let's find this logic. I've just noticed I have a tremendous salad of, I don't know if you folks can see it, it's kind of small. Over here, see that? Random mixture of underscores and hyphens in file names and stuff. What do we think? Hyphens or underscores? What's better? Because I don't know. I'll fix it later. It's easy to fix, I just need to pick one. And then rename a whole bunch of things. Alright, basic logic, logic precedence, unary not. So logic precedence is here. So this is going to be print true and true or false. Print false or true. How does this work? What mine's closer in like JavaScript? Let's have a look. I need an example of an expression which is ambiguous. Like one where the operator precedence is what? Yeah, it needs to be this. False and false or true is true. Yeah, that's the precedence we need to put in. True or true and false prints. So what is that going to print? That's going to print true. Snake case for JSON, camel for variables, and the class case name for classes. Pascal case. Big P, big C, Pascal case. Unary not in Rockstar is all binds tighter. Precedence. Operator precedence. All right, so logic method should be true, true, false, true, true, but what's false, false, true, true, true? Yeah, no, that's correct. Hang on, that's not. False nor false is true. Okay, precedence, binary operator precedence binding. What binds tighter than what? So if we've got that one's pointless because they're all the same operator, so we don't get any indication of how the operators bind coming through that. So false nor false. Should be true. So print false nor false. Is true. Yeah. Right. So I just need to figure out exactly. So what do you expect this to do? False, nor false, or true prints true. Now, if or binds tighter than nor, that whole expression there, false or true, is true, and false nor true is false. Let me see how other languages do it. Particularly if there's a language out there which has a nor in it. What do we think, folks? Should I just cut nor out of a language because it's too confusing? Let's take a look in the previous incarnation. Rockstar.test fixtures, operators. Nor means not and not. Yeah, that's correct. So A nor B means not A or not B. I don't know why it's in the language spec. I don't remember putting this in the first version. So either it was just a good idea or it was in one of the... A lot of the stuff in version 1 I was sort of learning the grammar stuff as I was going along. Kind of still am to some extent. And so there's a bunch of stuff in there that was just like copied and pasted it from somewhere and it worked, and then it's part of the language now. So what do we expect? Not false or not false? Or false. So yeah, so that should print true. That makes sense. Which means that print false nor false or false should print true. And print false or not false should print true. So prints false or false nor false should print true. And yeah. And it works. It doesn't cost anything to keep it in. I just want to understand the precedence of it so that we know exactly how it's gonna behave. And so false nor false there should be not false or not false or true, which should definitely be true. So I just need to switch the binding order of those two operators there. So rockstar.peg a binary or. I just so figure out another couple of test cases here. So if we've got print not true and not true or false or true, hang on. Now that should print true, which means prints true nor true or true should print true. And print not true and not true and false should print false. So print true nor true and false should print false. Alright, so I think it's just the precedence of nor and or that's the wrong way around. So if we go into the grammar file here, and I'm just going to say that a binary, so that one needs to move up. So a binary or then is defined as a nor or an or a nor. And a nor is defined as an and, nor, a nor, or as an and. And an and is defined as equality or thingy. And I've forgotten to... What have I forgotten to do that? Ha. Boom. There we go. That's how it works. Alright, so logic precedence now. So I can take out that line, that line, that line, that line, and that line. And that line. And now I just need print true and true or false. Prints true, print false and true or false, prints false, print false and false or true, prints true, print true or true. True or true and false prints true. All right. So binary logic, keywords and, nor and nor. Yeah, alright. Stony, you've been awake for 24 hours fighting with EF Core and CSS and yelling and swearing. Yeah. Break. Alright. Cannot find a file examples 04 boolean logic operator precedence.rock because alright, rebuild that, jump over here, localhost, reload because I've changed the file name, binary logic. Okay, it hasn't built the new interpreter yet, but that's coming through. That's coming through. Yep. What do you call the thing where you use binary operations on other types? Short-circuiting. I can't spell evaluate. That's fun. I'm going to change that to X and Y just because I think it makes them a little more... Evaluate X if the result is true, otherwise evaluate that, which means if X is truthy, Y is never evaluated, and then X and Y. Evaluate X if the result is falsy, return it, otherwise evaluate B and return that. If X is falsy, Y is never returned. So X nor Y is going to so that's not X or not Y, which means it's going to do the same. Evaluate X. I'm going to come back to this once I've actually built some examples of it. Basic logic, entering not. Let's Control C one of these. And rename that. Boolean. We'll call this short-circuiting, I guess. That'll do for it. All right. Print hello and 0, prints 0, print foo and bar, prints bar. Give me a failing test, come on. No. Really? All right. Take it easy, Stony. Get some sleep. Do not attempt entity framework entity framework after being awake for like 50 million hours. So I'm sure there's a name for it. Like, I'm sure the internet knows exactly what to call this thing where you return an operand from. Let me see what the JavaScript language documentation. JavaScript and or returning operand, not Boolean. What do they call it? The OR operator actually returns the value of one of the specified operands. Nope. Yep. 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 I'm gonna chop that out. There we go. Call it binary operands. Why not? That's a good name for it. All right. What did that do? So that's a shortcut for print not true or not 1/0. And yeah, that's the wrong way around. So true. Yeah, that should short circuit, and it's not. That should be that way around. I think. Not A or not B. Let me check somewhere here. I had a truth table for NOR. Where did it go? NOR gate. False, false is true. Anything else is false. False, false is true. Anything else is false. That is correct. Binary evaluation here. False. False. Is true. But doesn't short circuit. Which is weird. No, it's not A or B. It's not A or not B. I thought. If the left-hand side is false, it has to evaluate the right-hand side. Ah, yeah. So that should be... It's that. I think. Yeah. Not A or B. So that, the logical short circuit there should come out of that. Yeah. That's it. Thank you, SigStackFault. I'm good with loops, I'm good with parsers, I'm good with geometry. Operator precedence just bakes my noodle. I also haven't actually defined what happens in Rockstar when you divide by 0 yet. At the moment, you got a .NET runtime error. Folks, I'm going to do about another 15 minutes, and then I'm going to call it a day, wrap it up, go for a walk, enjoy the fact that it is not actually raining right now. So, all right, so what do we got? We got that, we got NOR. Let's implement comparisons. All right, so we're still in. Yeah, Boolean logic is good. Right, grab that, copy that, right-click that, rename that. We'll call this equality.rock. So print 1 is 1. Let me check my keywords for this. All right. Mm-hmm. All right. Is, ain't, is not. All right, so what do we got? We got a one, two, 0 is true. That's not correct. Print 0 is false. Yep. New keyword. Bah, bah, bah. We should have like a little kind of, alarm bell that rings for that. We're going to implement a new kind of equality. So as well as... I just did the thing, didn't I? Where I copy and paste the file. So that lot comes out of there. That goes into equality.rock. I then take all the stuff out of there. I save that. I come to the end of here. I chop that out. I go into there. I save that. So unary not.rock is now correct. There's that. But equality.rock, I'm going to copy and paste this. And I am going to rename this to identity.rock. Okay. Equality. The reference rule EQ does not exist. All right, operator equals, and that one is operator dot not equal. Why do I actually have an operator? Equals and not equals, yeah. All right. I need to plug in a new keyword here. Oh, that's fun. We're going to get comparison in, then I'm going to wrap it up for the day. This is definitely one of those, I am too busy concentrating on programming to tell entertaining stories while it's all going on, but that's fine. We can figure that out. Okay, so let's take a look at... Alright. I don't know how to apply equals to number. Alright, now that's the fun part. So, create method value.equals. Now I have an implementation for this stashed somewhere. There we go. So if I go into value.cs, which is there is a method on this called equals. Now this is the chunk of code that I kind of feel like it should be somewhere else. Like having this all inline in value feels a little bit like overkill. And I wonder if I can push this down to... If I make that abstract and take the body out and build that. Okay, the compiler, the parser's still complaining, but it's got out-of-date stuff on it. So let's create that in there. Yep. And we'll plug in that as an abstract method as well. Now I think there. Not booleans, booleans. So what do we got? We got a public value abstract boolean equals to not identical to. So that there I can now just flip, because this is gonna be I overload a bunch of operators here. Let me have a look at value.cs. There should be operator overloads in there. So if this is a string, then we are gonna say And then identical to is going to be value is string. Where's the parser for Boolean logic equality? 3, 4. So, hello, Kelly. So equals is because I can't use a regular equals because in .NET equals already means something, and that's interesting. Why is that blown up? That shouldn't be there. So there's a couple of places where I've had to put. I needed some way of disambiguating the stuff I was doing from the stuff that was built in, and so I decided I was going to put heavy metal umlauts on all the things. So output equals number 0 boolean is true, number 0 boolean false. So that's all good. It's just not working. Why is it not working? Should be true, 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 but was true, false, false, false. Am I just stupid? 1 isn't 2. That should be true. Okay. So let's go into a thing here, and Ooh. Okay, print 1 isn't 2. That should not be difficult. So what I want to do is let's go into the resolve, binary.resolve, operator.not equals. So I'm going to stick breakpoints on that, that, and that. I'm going to right click that. I'm going to debug that in a new task runner process. I'm going to step in and see if I can figure out why the heck it thinks these things are equal when they are clearly not. So what do we got? Let's step into not equals. So eval here, this is going to give me back a value. What have I got? I got a rockstar.values.number. I've got not equals, so let's step into that. And that's going to step in. Oh, that would be why. Yeah. I'm just dumb and forgot to negate the logic on the rule. All right. So now I've got true, 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 false, which is interesting. Because, oh, hang on. We might have found an interesting thing. So let me have a look at the parse tree for this. So the parser for equality.rock is, if I take a look at the source code here, print 1 is not 2. Yeah, that's interesting. The is not there is binding tighter. It's doing a unary inversion on that. So that should actually be false. Yeah. All right, let's find the failure. Chop that out, save that. All right, so it's something in the way the eval expression works. Binary.resolve. This is going to need to be a more sophisticated breakdown here. So camera's frozen again. Folks, we're going to wrap this up because all my cameras keep overheating. Thanks for tuning in, gang. How long is that? 3 hours, 41 minutes. Yeah, we got a bunch of stuff done. I'll have this done for the next one. Take it easy, folks. You have fun out there. I'm going to go out, take a walk, enjoy the evening. Catch you next time.